in May. Today we are welcoming Andrew Ardington from the Regen Agriculture Society of South Africa. He really needs no introduction. He's a familiar face here at LaRSSA. He's done a couple of web chats for us, and 2 years ago he facilitated part of our pre-conference workshop on regenerative agriculture. So we're building on that and the increased interest in regenerative agriculture. So what Andrew's going to talk about today is how to help our severely impacted and disturbed land and getting it out of the hospital, as he says, and into the physiotherapist care. And then just some background on Andrew. Like I said, he's the founder of the Regenerative Agriculture Society of South Africa, and he's also an agricultural economist by training. Thanks, Andrew. We'll let him get started on his presentation. If you have questions, drop them in the chat box. There's a little Q&A box. I will consolidate them from there. At some point, we'll stop and take questions, and then we're hoping to have a very lively discussion afterwards. And thanks for joining. Thank you, Andrew. Over to you.
Thanks, Helene. Good morning, everybody. And I'm very excited how these two worlds, the world of rehabilitation and regeneration, are coming together. And I'd like to thank LaRSSA for all they've done in that regard, and especially Teresa and Helene, who drive all of this and make these events happen. And to all the others online, thank you very much for your time. Time is precious, and so it's a privilege for you to give me your time. I don't know how many of you have watched the movie Roots So Deep. It's a wonderful regenerative documentary about some science that was done in the southeastern United States. And there's one brief little part of this movie which really caught me. And it's a chat between this guy on the screen, Michael Lehman, who's a soil microbiologist, and the filmmaker, Peter Beck. And Peter Beck wanders over to Mike and says to him, or asks him what he's doing there. He's digging around in a bucket. And Mike responds that he's preparing some soil samples to analyze. Peter says, "Are these microbes important?" Mike responds to that, "I would say so." And Peter says, "How so?" And Mike, in his typically understated way, says, "Well, they kind of run the world. Without them, we wouldn't be here." And that is true. It was quite interesting. In this project, they studied regenerative farms next to not regenerative farms, and the soil microbiology on the regenerative farms, well, there was 25% more species and activity in those soils. So the soil plant ecosystem is what has made this 4.5 billion year old planet habitable for us humans. And that ecosystem is largely controlled from the soil to the climate by more than 1 trillion different species of microbes. And for us as humans, it is critical, especially if we're involved in land rehabilitation and regeneration, that we understand the importance of ensuring that these microbes have a healthy place from where they can run healthy ecosystems. Now, land rehabilitation has been around in the science and in the news in the world much longer than regeneration has. Regeneration is a relatively new entity. And of course, these names immediately raise the issue of definitions. I'm not great on a definition for regenerative agriculture. I think one of the problems we've had in the past with natural farming systems is that they've been narrowly defined, and those definitions have led to the exclusion of a lot of people. Where we sit right now, or the state of our ecosystems, we need to be as inclusive as possible, and so we don't want any exclusive boxes. So I've made my own boxes when I come to think of a land project and rehabilitation and regeneration. And for me, the difference comes down to money. A rehabilitation project is one that is going to require money for some time to get going, to get better. it requires an investment and an input of a much longer nature. A regenerative project should be able to self-regenerate, to be able to build itself once it's got going. There will be an investment required in the beginning, but it should soon become profitable and be able to pay its own way. Ideally, all rehabilitation projects should become regenerative projects. But we all know that at the end of the day, there are going to be some projects that will remain in that I need money state forever, needing external support, such as the nature of our current economic system. So on that subject, I'm a supporter of external support in the form of ecosystem service payments for land. If we look at land, we currently find ourselves in a situation where we need farmers and land stewards to provide us with a number of ecosystem service payments. The ones I always talk about are food, water, air, and a stable climate. You can see this picture from the Food and Agriculture Organization has 11 different services that we require from land. But we only pay farmers for one of them, for the provision of food, fiber, and fuel. And if you only pay for X, you only get X. Your chances of getting X plus 10 are very limited. And so somewhere, something's got to change in our economic thinking, but that's not our subject for today. Our subject today is more about the soil. And what we really need to understand is how bad the condition of much of our soil is. And I'm not just talking about bare ground that we see as we drive around, and the erosion and mine dumps and obvious places where we have turned soil to, as the Americans say, into dirt. But the average soil inside the average millie field in South Africa is in a pretty disastrous state. If you look at these two pictures, these two little blocks of soil, spades of soil, come from right next to each other. The cultivated land has been cultivated for many years. The good-looking soil on the right comes from the edge of the field, from the venaka, and there is often a fence there. And that fence that's been there for, say, 100 years has protected that soil in a way that the soil inside the cultivated land has not been protected. So it's had no cultivation. It hasn't had a big piece of metal come through the house and turn it over and rip up all of its infrastructure. It hasn't had any synthetic chemicals applied to it, fertilizers or other chemicals. It's had no compaction from chemicals also, and from vehicles driving over it. And it's never bare. It's always got grass, even if that grass is dormant, lying on top of it. And that is very different lived experience from the soil on the left, the cultivated soil. So when we're talking about these soils that are degraded, we're talking about soils that have entirely lost their architecture, their biology, and their function. The aggregates, the pores, the organic matter, the microbial communities, they're all pretty much gone. Whereas on the right, you have this healthy sponge-like structure full of spores and lots of roots and microorganisms. And it's a healthy home where we can have healthy microbes running our planet for us. Here is a closer zoomed in diagram of that soil. And you can see the bits of organic matter and the aggregates and the pores, and the pore spaces that allow the soil to breathe for gaseous exchange, because soil is a living entity. All of these things inside the soil, the fungi and the bacteria and the mites and nematodes and various other living creatures, it's a living, breathing entity. And when we compact it and remove its pores, it struggles to breathe. It also struggles to absorb rainwater, and it's hard for roots to grow through it and to access the water and nutrients and elements that it needs. So this little picture, just I was discussing with Dr. Hendrik Smith, who many of you might know, our soils are actually in ICU. That they're in ICU, and the only way that we can keep them productive is by feeding them an expensive and destructive array of man-made chemicals, or what the current industry calls crop nutrition and crop health products. And when we look at rehabilitating soils or regenerating soils, we really need to grasp that. And we need to grasp that the plants that are growing inside our modern agricultural fields are plants that have, through breeding and hybridization and GMO, been designed to live off a life support system. And for me, the regeneration rehabilitation process is about getting soils out of that ICU to get them into the general ward, and finally as outpatients where they can get better on love and grandma's chicken soup. Too often we suffer from the too much Kool-Aid problem in the regenerative world, and people just think that they can jump straight towards the grandma's chicken soup solution. But we can't. We have to realize where we are. We have to be realistic, and we have to take all the steps that are required along the way. I'm sure many people on the webinar today know Mark Aiken, and this is a slide of his I stole from his presentation a few years ago in 2019. And you can see the deconstruction and reconstruction of the layers on a strip mine. And the layer I'm most interested in is layer F on the right-hand side, the topsoil, or we should say the want-to-be topsoil. And if you look at all the things that are done to this topsoil, going across to the other side of the picture to where it's called A, it's taken off there. It should be put down somewhere separately. And then when all the other layers are put back together, put on top of the other layers, and then that becomes the topsoil once again. But even if that's all been done correctly, that topsoil hasn't had the greatest of times. And we need to understand that it's also going to be an ICU. And grandma's chicken soup is not going to be good enough. Sorry, I don't know what happened there. So we need to understand that if we're going to go the route of going straight to cropping in a system like that, it's going to be a high external input system. And external inputs are energy. And energy, as we know it, just gets more and more expensive. When we use significant amount of external inputs on soils, we also don't improve those soils. And thereby we buy into a lifelong high input, high risk farming journey right from the outset. Now, what I want to talk about a bit now is different strategies, perhaps, for looking at how we get that soil out of ICU, rather than this permanent patient status that we currently operate in. So we were all told at school that it takes 1,000 years or thousands of years to make soil. And that's correct. It takes thousands of years for rocks to become topsoil. It's a long, slow process. But what we can do in recent times with better understandings of these of soil is take subsoil very quickly to become topsoil. And that way we can get much more quickly out of that ICU status. A great way to do this is with cattle. We don't start with planters and fertilizers. We start with something that I generally don't like to advocate for, and that is feedlots. But these are feedlots with a difference because A, they are mobile, and B, they are designed to make topsoil. These pictures are from a mine rehabilitation site in South America. So I don't like feedlots because they make externalities. But I have to admit that despite these externalities and my dislike of them, we're actually very good at running feedlots. They fit very well into the human sort of business framework. We remove nature and that variable, we take control, and we run a business and we excel at running that business. We're efficient, and then we're also very efficient at forgetting the externalities. There was a famous conservationist in the United States called Wendell Berry. And when he was living at the time when they separated cropping systems and livestock and made them into two separate individual systems, the one getting fertility out of a bag and the other one living in a feedlot. And he wrote that the genius of American farm experts is well demonstrated here. They can take a solution and divide it neatly into two problems. And these mobile feedlots on highly degraded land give us the opportunity to slightly rewrite that story around feedlots there, where we can take one of the problems, which is waste, and turn that into soil fertility. So imagine a feedlot with greatly reduced externalities. You place it on a degraded piece of ground and you can make it mobile. And that's where the magic lies, in the mobile. By moving along, you get no buildup of the byproducts of a feedlot. No organic matter, water, urine, and dung accumulation to the degree where they become negative externalities. Rather, they become part of building your new soil. And into that mix, you can scatter seeds, which are planted by the hooves of the animals. And once you have done this process sufficiently, grass begins to grow. And as we have seen from many regenerative projects, other seeds introduce themselves from other places. When these grasses are set, we can change from a mobile feedlot to grazing at much higher densities. And the process of regeneration continues. Over time, a lot less time than you think, better species of grasses and forbs are what our grandparents used to call weeds, will return to that soil and help to regenerate it. And after that, we can think about row cropping in those fields. That is, if we still want to. So all of this works largely based on the fact that herbivores are such inefficient eaters. They are large cyclers of nutrients. And if you look and compare that to a cropping system, especially one using synthetic fertilizers and chemicals, a large amount of the inputs there, the nutrients and elements that go into that, are lost. They're lost via oxidation, and they're lost by leaching into the soil. So if we look at these primary inputs of agriculture, NPK, nitrogen, phosphorus, and potassium, a cow eating grass and taking in nitrogen from that grass, within a day, 90% of that nitrogen has passed out of that cow as urea into the soil. And with potassium and phosphorus, most of that goes out in the dung and it's slightly lower numbers, and it varies depending on different times of the year. For instance, if the cow is lactating or not. And so these elements that are biologically available are immediately returned to the soil and enable this rebuilding of the soil to take place. So when hearing about regenerative grazing and its capacity to fix the soil plant ecosystem and to help us with our farm economics, people are often skeptical about this. And especially when they hear about the improved grazing and how that can improve to the degree where we can improve or increase stocking rates on land. This all seems counterintuitive because for so long we've had the narrative that livestock are destroying our land, and we need to decrease our stocking rates rather than increase them. But by changing the way we graze, we can work with the soil plant ecosystem and improve its function. And we can improve it to the degree where achieving twice the biomass it currently produces is not that much of a challenge. And we must consider that comes with all the associated ecosystem benefits of that additional biomass production. At the heart of getting this regenerative grazing right are a few management principles. And the first one is that we need to evenly spread our herd impact. That distribution of NPK has thus far in grazing, especially grazing like continuous grazing, which we'll discuss more of shortly, been very, very uneven. And in order to achieve this, we need to achieve a certain density of grazing. High density creates high herd impact, and a lot of attempts at regenerative grazing don't succeed in bringing about the potential change because high enough densities are never achieved. Then the next principle is that of appropriate recovery. It's very important to allow these grasses to recover, especially new ones that germinate, before we graze them again. A new germinating plant can just be ripped out by its roots as a cow grazes it. And if we don't allow these new plants and returning better species to recover and rebuild their strength appropriately, then we continue with the negative impact of grazing. And then the principle of being adaptive. Regenerative grazing is a hands-on grazing system, and it's got to be adaptive, and that adaptation needs to be governed by the recovery of the grass and the performance of the animals. And so it is in that part both a science and an art. And getting that right is where the magic lies. So continuous grazing, that's where animals are left in camps for a long time, sometimes 3 weeks, sometimes, 3 months, sometimes a whole year. In this picture on the screen now, this is an experiment that was done by Richard Teague, Professor Richard Teague in Texas. And the cattle were inside this camp for a year. And is basically the whole farm. And he put GPS collars on them and tracked where they spent their time. And you can see in that picture the white boundary of that camp. And the green dots represent all the GPS areas. And 41% of the points were recorded on 9% of the area. So these parts of the farm have been incredibly overgrazed and overdunged. And then the other parts, the large gaps in the middle, which have received almost no cow attention, these have suffered from the exact opposite scenario. They're undergrazed and they have no nutrient cycle functioning at all. Now, just imagine what you could do by adding a few extra water points in this scenario. All of those spots would now start attracting cattle, and the grass ecosystem, the soil grass ecosystem around those areas would start to get the benefits of these interactions and spread out the impact much more effectively. There are lots of other studies that have been done on regenerative grazing. And it's interesting that already at 400 meters from the water point, the animal impact is starting to drop off. And by 900 meters, the herd impact is no longer there. The animals are meandering, they're being too selective, they're not applying their herd impact in the way, in the manner that it needs to be applied. And the accumulation of urine and dung happens in specific areas. You saw in that previous photograph, along in the valleys and at the water points and at the lick points, you get this massive buildup of nutrients. And in the rest of the areas, the grass is not getting the love that it requires. And conventional grazing, both herd impact and herd density are very low. So that situation of spreading the water can be, you can use then grazing strategies to off that water, increase the densities and increase the regenerative impact. If you look at this setup here, this is a lovely farm. It's a perfect rectangle. And there's a nice water point, a water pipe running straight through the middle. And the two big blue dots are water positions, water points. And if you divide each camp up into little strips with polywire or herders, you can slowly take your cattle through that strip or through that camp and all the way along create higher herd density and higher impact. So, of course, somewhere in the middle of this creating higher impact and carrying capacity comes the sweet spot between economics and the results you're getting, the regenerative results you're getting, and how you can optimize that is really the important thing that the land steward has to get right, and that is context specific. So what does this herd impact actually do? Or what is it and what does it do? As I said, herbivores, cattle are big recyclers. And in the process of interacting with the grass and the land, they graze the grass, they trample what they don't graze, their hooves cut the soil, their saliva stimulates regrowth on the growth points of the grass where they have grazed. Their urine, I pointed out earlier how in a day, 90% of the nitrogen that went into their mouths exits in their urine, and in 90% of that as urea, and then lots of others in their dung. And associated with that dung, with that urine, with that saliva, and indeed even with their coats, there is this multitude of microbiology that is now interacting with the microbiology of the soil grass ecosystem. And together they are stimulating the whole system and taking it to function at a new level. So rest and recovery. Rest is not as important as recovery. Rest is actually just the period since the grass was last grazed, but that could be it could have been grazed in May and then again in August. It's not going to get any recovery in that time. That's in the middle of winter for most places in South Africa, and most farms do very little growing at that time of year. Recovery is the time period where the grass actually is actively growing, and recovery is crucial. If we look at these images, this was an experiment done to look at the impact of the lack of recovery. And so on the left, that grass that has very little roots, a very weak root system, was cut down to 2 inches once a week. The middle one cut down to 2 inches every 2 weeks. And then the third one also cut down to 2 inches, but every 4 weeks. And you can see what has happened to the roots in that process, how those roots have died back from that repeated utilization because there's been no recovery period. Recovery and rest. Let's talk more about recovery. Recovery can vary significantly. In KZN in the Midlands, 21 days later in December, you can be back in there and grazing again. In Beaufort West, in the Karoo, it might be 450 days before you're back in there to graze again. So once again, highly context specific. And it's incredibly important. Now, one thing that is really little spoken of and heard of in regenerative grazing is the impact of this grazing system on animal health, and how animal health improves, and as a result, the amount of routine treatment of animals that is required can decrease. And of course, that has a lovely economic impact. You spending less time gathering animals around, bringing them together to work them in the yard, and you're spending less money on dewormers and porons and other chemicals. But from the biological perspective, from the soil plant ecosystem perspective, the dung is no longer deadly. And that can have an amazing impact on that soil microbiology. And there are farms where the adult people living on the farms had never seen a dung beetle on that farm, and dung beetles have now returned and added their ecosystem services to the package. And that's just a nice big creature that we can see. And with it comes a whole bunch of other microbiology or parallel with it that we cannot see. But all of that really makes a big impact on the ecosystem function. This is not saying that we can go cold turkey on this stuff. There are parts of the country where our ticks are very, very nasty. And we need to do all of this in a strategic, practical, pragmatic way, rather than just go charging headlong in it. It's a little bit like the ICU scenario. We can't just go straight to the good times. Now, water infiltration is a massive thing. I live in the Western Cape, and we've just had horrendous floods down here. And our country's ability to infiltrate and hold water has been so degraded over the last 300 years that we have huge amount of runoff and a lot of damage. We have a place near the Breda River, a small holding, and there are whole towns there that have basically been damaged by these floods. The floods didn't even happen where they were. They were up in the winelands. Yeah, this situation, if you extrapolate it from the Western Cape to the Eastern Cape Highlands, where you have well-watered mountains that are above towns that are in perpetual states of zero water. I get that some of that is a management capacity, but it's also that the water systems, the water infiltration, the water cycle is just not working. And with more water in the cycle, in the ground, we can have more photosynthesis, and all the good things that we know come from having more photosynthesis. And for the farmer, the fact that the ground is holding more water, it means that those dreadful midsummer droughts that we get every year, and that seem to be getting longer and longer. This year's one in the Free State was a good one. The effects of those are reduced by this water holding capacity. And farmers are often able to plant earlier as a result of it. And then improve biodiversity. I know that a while ago on this LaRSSA series, we had Fritz van Oudtshoorn talking about his study on Donnie Slubbert's farm and the amazing change in diversity there. And I've been fortunate enough to travel around the country and go to lots of farms and see similar results where long lost grass species have returned, and forbs and legumes that farmers didn't even know existed. They thought they only had grasses and they only had these few grass species. They now have many more grass species, and these seeds, they haven't introduced them. Those seeds have been sitting in the soil waiting for the good times to come back. And when the good times have come back, they've germinated and expressed themselves, protected from being overgrazed when they're young. They've been able to get a foothold and become part of the biodiversity of that farm. But for the farmer, they have significantly improved their grazing because they've improved the palatability. These species are generally the more popular ones that were grazed out by the selective grazing cattle and sheep. And now they're coming back. And they're also often cool season plants, so coming at the beginning and the end of the season. So all of this then adds together to create a healthy soil plant ecosystem that is functioning as it should be. And if at this stage we still desire to take this ground, say after a decade of felt lotting or feed lotting and high density grazing, and take that and make it into a cropping system, we're able to do that, and we're able to do that on the more grandma's chicken soup and love scale than the high input lifelong support system of the ICU soil. So I just wanted to introduce this concept today to discuss in this group of people the really bad state that our soils are in, and how we do not want to set ourselves up for failure by thinking that we can just go charging in and make the whole system fixed right again, and that soil that's compacted and lifeless is going to immediately be supporting a nice mealie field for us. There is a process. People often look at regenerative farming as if it's magical. I say it's magical in that in conventional farming, 1 + 1 = 1.5. In regenerative farming, 1 + 1 + 1 = 3. So there's no magic, it's just no big subtraction. And so, yeah, thank you for your time and listening to my talk. And I hope that we get to have some good conversation around it. Thank you.
Wonderful. Thank you, Andrew. I think I'm experiencing a technical issue because I'm unable to see or add to the chat box, so I can't actually see if there's any questions in there. But I think what we should do is unmute everybody and then enable them to raise their hands, and we can have a discussion. So please, everyone, just raise your hand if you'd like to ask a question, and we would like to encourage that as well. There's one, the first one from Heidi. Please proceed, Heidi.
Hello, Andrew. Thank you very much for a very fruitful discussion. I really learned from you, and I like the soup analogy that you made. I come more from a remote sensing of wetlands, and one of the arguments I presented earlier this year is that we really need to understand the infiltration capacity of soils in catchments and how they can supply groundwater and ensure that we have wetlands that are groundwater dependent actually become the refugia during drought years. And now you touch base on the restoration of these. So for us, we have to do global biodiversity framework reporting by 2030 for target 2, saying whether we have 30% of the extent of degraded systems under restoration. And I have been very eager for someone to tell me whether South Africa has started mapping the extent of rangelands or catchments that are under restoration for soil to facilitate better infiltration. Please tell me if that is ongoing, and if not, how can that be done or facilitated?
Thanks, Heidi. The sad news is no, it's not. There's very little research being done on this. I know of one specific project that's published a paper already on comparing 11 different regenerative farms to 11 other farms. There's sadly, if we look, even just take base soil science measurements outside of our cropped lands, we don't really have a repository of soil science data. I had someone contacting me this week and saying, "Oh, we need to do a microbiome analysis map of South Africa." And I'm like, we haven't got a soil map yet. We need to for rangeland areas. There's very poor data out there. And yeah, we really need to understand the importance of this. They've said for a long time that the Third World War is not going to be fought over oil. It's going to be fought over water. I think Donald's trying to unproof that statement, but forgetting about that. We really do need to understand how important water is. Sadly, there doesn't seem to be a coordinated effort. Well, maybe there is. I don't know about it. And I've been looking around. I started out my journey 7 years ago, traveling around, finding regenerative farmers and looking at comparing practices to see, what was working, what wasn't working as well. And could I find commonalities of that? And I've come across in the process some beautiful farms. But sadly, the vast majority of the driving between those beautiful farms is a pretty depressing experience.
Thank you very much for that reflection. And yes, just two responses to that. I know that the Agricultural Research Council is busy with starting with soil sampling and ensuring that we are starting towards a soil map. And I think there's various ways that many communities and researchers or universities can start contributing to that through their work as a heads up or a bottom up approach to really improve that. I don't know if you want to respond before I say my next statement.
If we could break Chinese walls and silos, we could make some great progress.
Exactly.
There's an enormous amount of individual science, even just at a one farmer by themselves level. Then you take that to the agronomist who aggregates a couple of hundred farmers. Somehow we need to convince people to make this data public. There is an enormous amount of data out there. It's just unknown about and locked up.
I completely agree. And that was my other last statement that I wanted to say, because I do think farming communities have a massive role that they can play in contributing to understanding the catchments and how we can improve them. But isn't there also sensitivity that people are pointing fingers to them saying, your land is degraded, and that they don't necessarily have the financial means of improving it. And that for me is sad, because it's not about pointing fingers. It's more about how can we focus attention and maybe resources coming in for restoration, and that funding, can we channel it in the right direction? Thank you.
Yeah, I mean, that's what you say is so true. We have to understand that this is a food chain issue. It's not a farmer issue. Okay, and if you look at it just at a money perspective, which is always dangerous, but farming, primary agriculture constitutes 3% of the world's GDP. 97%, therefore, is not involved in primary agriculture. And this pipe dream that the 3% is somehow going to invest in and fix up the millions and millions of hectares that we need to fix up, is not going to happen. That 3% is not only a small number, it's also a highly indebted 3%. So, we've got to have a bigger solution, a bigger version of what the community is. And we need to convince people that, that aggregated soil data you have is actually better in the public commons than locked up in some cupboard somewhere where it's not helping anybody. Morning, Albert.
Hello. Yes, can I make a comment?
Yeah.
Okay, it's a quite interesting topic. I think some hydrological modeling would be great to do, especially a bit of hill slope hydrology, because especially for wetlands, you would like to have a more gradual water flow through the wetland. And actually, it was a degraded land. We sit with storms and droughts. And I think that is one of the best ways of killing a wetland. So I think if infiltration rates are being improved or from regenerative agriculture, it's not only infiltration rates, but also the soil water retention and storage is being improved. So hydrological in the bigger area, the effect on groundwater and the effect on rivers, and especially the effect on wetlands, are that there's a change from a storm water effect to a base flow. So base flow, storm water is you have a lot of runoff from the surface into your streams and sun, and then the water is gone. The base flow is more gradual, so water flows through your soil and slowly through your various sort of layers below the soil, and then you start to get a lateral feed to your streams and your wetlands and rivers. So they refer to this a hyetograph. So a hyetograph is basically what's the relation between rainfall and your runoff. So we actually need to change that hyetograph. So I think we don't need a bit of hydrological modeling to see how is the storm flow versus the base flow is changed with improved land. And I think that will give us, because that also links in your land directly with the wetland system or with your streams. And I haven't seen that type of work being done, but I think that would be quite important study. Secondly, it's not only about infiltration rates, it's also about the soils to temporarily store water, and that rainfall water has been released more slower over time. And the topic now is wetlands, but there's another one which can also add. It's in terms of our water reservoirs, our big dams, Fall Dam and so on. We would like to have in dry years some water in our dams, and in storm weather, like you experience in a Winston Cape, you would like to have a less of a storm. Now, that is exactly what happens if you move the storm water, part of that, to the baseline water. So yeah, just something to note.
Yeah, Albert, I mean, if you travel around, there's so many farms I go to where basically, what 200, 300 years ago would have been a very small wetland in a small valley, not even a valley, just a mild depression, it is now a 1 meter deep channel, basically designed to get the water off the farm as fast as possible. And you see this all over. You see this in cultivated lands. In some cases, in cultivated lands, it's deliberate because they can't grow when when there's too much moisture being held in the soil. In grasslands, it's not deliberate. It's as a result of poor grazing for 200 years. But yeah, I mean, what you say is so important. Yeah, I know. So they predict. It's always dangerous to work on predictions, but that's how we need to go. I'm sure everyone here is aware of that this next El Nino is potentially a major El Nino, and we're going to see how quickly our farms dry out. They're going to dry out very, very quickly. We've had 5
great putting things in the chat. Absolutely fine. So there's a couple.
We've had lots of water, lots of rain, for the last 5 years. It's been a good 5 or 6 years, but when it switches off, it's going to switch off rapidly.
Yeah, I don't know if you can remember when we visited Manny's farm, and I think we had a discussion on that. For me, it was quite striking. It was end of the winter, early spring.
Spring, yeah.
And the amount of water around his farm. There was a pool where birds came back and so on. And once we drove off his farm a bit further, you don't see any water or pools of water in perennial streams. There aren't any, and suddenly the whole land is just so much dry. And there was, that was a mental picture for me as a proof to show how regenerative agriculture can affect only the water balance and improves wetlands and streams and this water at the end of the winter on that farm. You can see. And once you're 2 or 3 kilometers away, you don't see any of that.
Yeah, it certainly is a stark place to visit in August.
Thanks, Albert. Andrew, I don't know if you can see the chat box. I can't, but Teresa says there's a question in there. If you can just take a peek.
Okay. I can see
Question
it.
by Nkululeku, or otherwise, if the person can speak up, that would also help.
I can't see I can see 4 questions. It says some people are outside my org. I don't know what org that is, but
maybe
I can only see the people inside my org.
Question is from experience, what is driving the current momentum around regenerative agriculture in South Africa? The farmer demand or genuine agronomic need? Is it driven by corporate chain supply, ESG appetite, international financing?
Definitely not the last thing. There's a severe deficiency of that. No, most of the regeneration is driven by individuals who, initially they were conservation-minded people who weren't farmers, but sadly that pretty quickly uses up, and then the next batch are people that realize that the economics of the current system is not sustainable for the farmer in the long run. If we look at our maize farmers, the stats from within the maize industry show us that every 15 years, half the farmers are going to exit. Okay. Now, if you don't want to exit, you're going to go, well, this system doesn't work for me. I need to find another system. And so that is a major driver for people investigating different ideas and coming across to regenerative agriculture. And yeah, there hasn't been a big corporate drive here in South Africa by anyone, really. There's been some stuff in the United States, but there's a lot of criticism about that, in that it's box ticking rather than actually really getting involved there. The one sector here in South Africa that has had corporate pressure is the wool industry. The fashion houses of Europe have cottoned on to the fact that they need to have regenerative wool if they're going to be making nice suits for people in 10 years' time. And so that is the only industry I've seen in South Africa where this external pressure has come in onto the farmers, to say you need to start moving in this direction. Other sectors not, and yeah. So largely, it's people who realize that this current model of farming is not sustainable for them personally in the long run. And I think that's the primary motivator that's going, happening there. Hi, Ed.
Andrew, yes, can you hear me?
I can hear you.
Andrew, thank you very much so far. So interesting. I'm really interested in one leg of the three-legged pot, as I call it, and that's the cattle. You mentioned cattle quite a lot, but the one I'm really interested in is the Nguni breed.
Yeah.
In my kind of research with the Nguni, most of the questions that are raised in terms of soil compaction, et cetera, and their urine and dung, probably the most nutrient one, come from Nguni, because it's not only a grazer, it's also a browser. And I also saw in one of your illustrations from that Texan farmer, a large part of that area that wasn't grazed was hilly.
Yeah.
Now, the Nguni is an animal that will graze anywhere. So it doesn't just graze grass, it also grazes all sorts of other plants. They browse. Isn't that a very good animal to have in our South African context? What is your experience with that?
So Ed, you're taking me to dangerous places here. You know that you should never get between a farmer and his breed of cattle. There was a nutritional scientist who said that you should find the cow that best fits your environment, the environment of your farm, and then fall in love with whatever that cow is. Sadly, we as human beings do it the other way. We fall in love with the cow, and then we try to change the environment to fit the cow, rather than having a cow that fits its environment. And I think what people are learning is that we had this European idea of what a cow should be and how big a cow should be and what a productive cow is, and then that got exacerbated by the feedlot system. The reality is a 550 kilogram cow in the veld in the Free State, that veld cannot sustain it. And it needs some outside help. And outside help, as I said, is energy, and energy is expensive, and energy is only going to get more expensive. So I think people are realizing that we need animals that are adapted to where you are farming, and that's both adapted in terms of their long-term genetics, but also in terms of actually adapted to your region, your weather, the plants you have, etc., etc. And our indigenous African breeds are finally coming into their own in that regard, and people are seeing this. And there's still issues with feedlots and whatever, but in terms of production on farm, there are more and more people that I'm interacting with and speaking to who are talking about adding in more African genetics into their herds.
Your feedlot that you talk about, feedlots used to be anathema to me until I've heard what you say there, and it actually makes sense. But I'm afraid that feedlots in our context in South Africa are not very conscious of what they are doing to the environment. And then that's probably why I was so anti them. But feedlots that are probably properly managed now can be of benefit to the ecosystem, or am I wrong?
Yeah, I mean, I think temporarily you can use them as a tool to fix things up. I think, we can't just carry on functioning in business models that have massive externalities. There's, we live on a finite planet, and we need to face up to that fact.
Thanks, Andrew.
Hi, Lynn.
Thanks, Lynn.
Thank you very much, Andrew. I just want to raise a comment rather that maybe we can take home and ponder, is that I think as society we're very quick to want somebody else to solve the problem, but a lot of what you're suggesting relates to agriculture, and as you pointed out, we're all dependent on food. And I think to a large extent it's up to us to become better educated and support industries that we believe are doing the right thing, instead of waiting for somebody else to solve the problem.
Yeah, all of those of us who are thinking about this and aware of this need to be applying ourselves in whatever ways we can, to making this whole system move. And so it depends. We all occupy, most of us either consumers at the far one end, or individual consumers at the far one end, or individual farmers at the far other end. Part of the food chain, and or fiber chain, and we all need to get involved in making it happen. So yeah, definitely agree on that.
Ed, do you have a second question, or is that an old end?
Sorry, I should have switched that off. Sorry, no, that was all. Thank you very much.
Okay.
I see Heidi saying here that will be needed in climate warming. I'm sure climate warming has its other friend called climate cooling. The climate warming that made our big storms here has resulted in some very cool times. So yeah, and there are parts of the planet that get cool, and we really need to look at products like wool and synthetic clothing, and cotton. There's an enormous amount of work being done on these different entities, and what their negatives are and what their positives are. And we have the capacity with a lot of with better livestock farming to actually fix ecosystems. And if the competing clothing to that is clothing that's produced as a byproduct of oil, we've got to look at that and study it up. But we're still going to be cold, and in some places very cold. Hi, Pete. But nerve-wracking when your uncle's got his hand up for a question.
I was going to ask if you're related. You've got to be.
I think maybe Peter hasn't unmuted his mic.
Fortunately, he hasn't worked out how to unmute yet, so we'll move on to Harlan.
Andrew, thank you so much for very succinct, in a nutshell, and informative presentation on this topic. Just a question, if you feel it would fit with the topic. It's a bit of a, well, I wouldn't say side issue, but you spoke there about, eliminating your parasiticides, your chemicals used for external parasites, internal parasite control with your livestock. And maybe if you can just expand on what some of the key elements are of enabling that to take place without sort of disaster or anything like that.
So I think if you look at a lot of our grazing systems, the continuous grazing system, everything's a cycle, okay? And we're very good as humans as breaking these cycles and making two problems where there was none, as was said in the talk. And if we're going to be making our cattle live with their dung for a month, we're going to be making them live inside disease cycles. Okay. And if you look at us as human beings, before we invented, sewage systems and modern sewage systems, and they have their own externalities, but before we invented them, there were a lot of problems in Europe around health and cities and that. We invented them and were able to to significantly decrease those things. So I think just the basic of moving your animals away regularly from their dung makes a great start on that. And then you've got to look at each thing individually and each farm individually. By improving animal health and selecting for animals that are resilient to ticks rather than just using a large amount of chemicals in order to keep them tick free. And that old saying of, we've spent the last 70 years making chemical resistant ticks rather than tick resistant cattle. And just need to start thinking like that and realize that there's actually an economic benefit in that for us as the farmer. There's an economic benefit in that we're not spending as much money on that process, but there's also an economic benefit in that we're going to make more grass on our farm because we're going to have a whole missing part of the ecosystem returning back to the ecosystem to help do that. And then, another big problem in many areas is liver flukes. You can use controlled cattle grazing to stop animals drinking out of water that they're dunging and urinating in. That's going to make a big difference to liver fluke problems. And so this is where it comes to what I call the precision grazing part of regenerative grazing, where as humans, you can control where your animals are and what they're doing. And just, there's research that shows that, forget about liver flukes, just the health aspects of drinking clean water as opposed to drinking water that the animals have urinated and dunged in is a benefit, an economic benefit. So those are various ways and aspects that we can reduce our reliance on these animals. And going back to Ed's comment, the African genetics has been here for 3,000 years, and only in the last 100 or the last 70 years has it had any of these chemicals. So and I'll see animals that have lived here for 3,000 years without chemicals now being injected all the time. But it is something that we need to take slowly and pragmatically, because you don't want to cause an economic shock on your farm. Hi, Pete.
Hello. I'm worried that the universe was sending me a message that I should stay muted, but here I am again. As you all know, Andrew, I live in KwaZulu-Natal, Midlands Misveld, near Howick. And the narrative around here, including a lot of the academic narrative, is that the management of biodiversity in the Midlands Misveld is best served by having no livestock at all on it, or if there are livestock, to have them at extremely low stocking rates and stocking densities. And I don't know where we go forward from this, because the understocking, if I put it that way, does rely on fire a great deal to stop ungrazed grass going moribund. Your take on
that? Fire is like cattle breed. It's a very dangerous subject in certain circles, especially in KZN. Talking earlier to Albert's question about the land infiltrating and holding water, they're parts of our Drakensberg mountain range where we burn the entire thing every year, and people, the farmers, are doing it to chase green, and you can only imagine what that's doing to the organic matter of that ecosystem over a long period of time, and those grasses are being grazed when they're very, very short. Where you come from, the particularly difficult part of the world with Ngongoni, Aristida jansiformis, causing lots of issues for land management there. And the reality is, I don't think, if you think what we can and we can't change in this world, I don't think we're going to be kicking cattle out of KwaZulu-Natal anytime in the near future. And I think what we need to do is focus on managing those in the most environmentally beneficial way. Then that starts a whole conversation about which aspect is more important of the ecosystem. Well, at the end of the day, we've got to work out, going back to Heidi and Albert's points, ecosystem function, the full picture. It's a complicated question you're asking. And I don't have all the answers.
Thank you for your comment. When I was in the army a long time ago, I was told during my introduction to the South African Defence Force that to avoid fighting amongst the troops, we should not talk about politics, religion, and women. And nearly 60 years later, I can add felt management to that.
We need to grow up and be able to talk about felt management without becoming, and breeds of cattle, without becoming so sensitive about it and bashing the conversation before it develops any real value and input.
Thank you.
Holland. Holland, do you have another question, or you just a lingering hand?
Andrew, sorry, I forgot to mute. Hopefully it's not contagious. Thanks for your response to mine and the other questions. Just a comment over here. I'm assuming there are probably quite a few folk who are new to the kind of regenerative farming concept and approach and practices, and thought just to make a note. I've made a note in the chat there just about the value of conceptual framework and a bit of knowledge and insight into what folk refer to as the 4 primary ecological processes and the 5 or 6 soil health or regenerative farming principles. And also just mentioned your website, the Regenerative Agriculture Association of South Africa website, and Understanding Ag in the USA, a consultancy there who have, I think, consulted on a cumulative 35 million acres now on helping folk transition to Regen Ag. They have some very useful info and links and stuff like that too. So I'm not sure whether the chat content will maybe be available afterwards, but have a look at those websites, have a look maybe at the comment I placed there just on just some of the basic framework, conceptual framework theory behind it. Thanks, Andrew.
Thanks, Holland.
Are there any other questions in that chat box, Andrew?
Not that I can see.
Okay. Okay. Would you mind if I ask a question? Maybe we can end up. Hello?
Hello. Of course you can.
There's someone there. Okay. Yeah, Andrew, I just wanted to ask if you can maybe end with some hope for us. So if I think of what we talked about from a mining perspective, there's the opportunity in that there isn't an existing farming enterprise that you have to convert now into a different management scheme, but there is the con is that the soil, as we discussed, is in a very degraded state. What would be your suggestion as to where to start? We always say start small, but what would you suggest? What would be the very first step? Would it be to focus on getting the infrastructure right, so the watering points, or would you focus on getting a herd going? Where would you start?
So the first thing is start small and start easiest. There are a lot of people think I'm going to go fix the worst part of my farm. You're changing your management system. You want to do your change of management system in the easiest part of your farm, not the worst part of your farm. So yeah, start small and start at the easiest part. The part with the nice grass rather than the part that's mostly not grass. That of course is very different in a mine reclamation situation. But water is the be all and end all of this. If I have to go back and look at the last 6-7 years of going to farms, is the people who have a good, well-distributed, resilient water system are the people who are in the position to bring about the regeneration at the fastest and best way. And the problem is that there's an investment required to make that happen. You can't get there without an investment. You've got to put some pipe in the ground, or put up a reservoir, or both. Put in a borehole, and if you shortcut that, then you're going to be paying taxes everywhere else along the system, and you're trying to implement a new system, and you want to reduce your taxes as much as possible. So yeah, so that water is something that I think should really be focused upon.
Okay, thanks, Andrew. That makes sense. Do we have any other questions? If we don't, Andrew, perhaps you can just end off, because I've got a little note in my hand here that I got from you at the conference in March. The little advertisement for your book that's coming up. Would you like to tell us about that?
Okay, I'll tell you about that. But there's Albert's got his hand up here again.
Oh, okay.
Or was that a mistake? Oh, it's not up. Yep, he's there.
Yes. No, for rehabilitation of mine lands, I think one should start first with grasses, with rangelands and so on, rather than going directly for crop production. So the physical properties and so on are the most challenging part. And you also need to get a bit of carbon in your soils to prevent some hard setting and surface crust forming, and also to get the structure so that you don't get a lot of runoff, lesser runoff, but for your grasses to get in a way a penetration into the soil. So I think that's for me quite important, is to start off with grasses, especially with very strong and aggressive root systems. Because the roots are the part that really contributes to the carbon and the structure and the better physical properties of your soil, rather than the upper part that can be grazed. But because the densities and so on are much higher than your farmland, I think that is why it's important to get grasses in with very strong and aggressive root systems and deep root systems. Do that for life system for 3-4 years or something like that. See what's going on, and then make decisions from there on. So there's also a thing of transitioning from ICU to the general ward. That transition part for me is a 3-4 year period of grasses. I don't know what you think about it, Andrew.
No, totally. I mean, that's what I'm suggesting. Just talking to Helene there about, like, if you want to do grasses and do them well, you've got to put water in. You've got to be able to keep those animals tightened together and be able to get them in there, make that impact, eat that grass, and get out of there before they do any additional damage. And their dung and urine must be nice and evenly distributed over that. And so, yeah, and then those grasses come in, and cattle are definitely the sort of the big bulldozer in this department. They make this happen properly. I have this unscientifically validated view on that. One of the things I think is that the cattle dung is very moist, and so it very quickly creates a link with the soil microbiology through that moisture. Whereas sheep have less impact because they're smaller animals. Also, their dung is much drier and sits higher up above off the earth. So, where I see change happening fastest is where there's high density operations with cattle. And a lot of those have cattle and sheep mixed in together, which I think is a great thing. We want to try and bring back as much diversity onto our farms. I know there's a problem with security around sheep in some places, and farmers feel that they just can't do it because of those reasons. But if we can have both cattle and sheep in our grazing system, they add different biodiversity of microbes to the system, and that's what we want. Okay, so thanks, Hillian, for punting my book. I wrote a book which is literally being printed this week. It's a very short book. It's a booklet. And it's not actually on regenerative grazing. It's on running a herd of cattle. It's based on a book written by an American conservation agriculture scientist. Well, not the concept, the idea is based on his book. He studied conservation agriculture and regenerative agriculture, and at the end of it wrote a book. And in the beginning he says something along the lines of, when you buy a washing machine, you get an owner's manual, but when you buy a farm and soil, you get nothing. And so he wrote a soil owner's manual, and so I wrote a little booklet that I've called a herd owner's manual. And it's literally about low input farming. And if we want to be economically viable in livestock farming in an environment like South Africa, we have to be very low input in our approach. To spend lots of money on external inputs that get ever more expensive is a race to the bottom. So that's what this book is that I've published, and will be going out. It's going to be available on Take a Lot, because that's the easiest way to distribute stuff across the whole countryside. So that should hopefully be within the next 2 weeks.
Excellent, and well done, Andrew. It's a big achievement to write a book. Yes, so I think we're done. We're at the end of our session. Thank you very much for all your contributions and your questions, everyone. We recorded the meeting, and Teresa will share the recording afterwards, or you can look for it on our YouTube channel. So thanks very much, and have a lovely day. We're going to end the meeting now.
Thank you. Bye.
Thanks, Hillian. Bye, everyone.
Okay,
Thank you.
bye,
Thanks
everyone.